Thursday, everybody. We got another experiment coming up today. But first, I want you to know about yesterday's experiment. Did mass change? Yes or no?
Yes.
Why did it change? Justin.
Mass did change because at first we had 70 grams, and then after the experiment we had 69 grams.
That's a great use of quantitative data and evidence there. Do you have the rationale to support it?
This shows that the mass changed because it went down 1 gram.
You explain the evidence, but you don't give the rationale behind it, the reasoning for that it went down 1 gram. Miranda, can we strengthen this argument up? You've got a great start, Justin. Yes, you're Miranda, aren't you?
This shows that the mass changed because the molecules escaped from the liquid.
All right, excellent. Excellent. Who can tell me about the environment that we were in? There's 2 words I'm looking for here. We've got a great answer by adding these 2 words. We're going to take it to 100%. Caleb. Yeah, Caleb. Just 2 words I'm looking for. What type of environment were we in, Julian? Nope. Air particles allowed it, or because we were in this type of environment, air particles were allowed in and out. Justin?
Open environment.
Close. Open. Open.
System.
You got it. Don't get it confused with that open circuit. Stick with open system here. All right, guys, I've got a question for you. So far, we've done 2 experiments this week. We've conducted one, making the glue, and we found that what happened to mass, Stephen?
That the mass changed.
Incorrect. Evelyn?
Mass stayed the same.
Exactly. In the glue, it came out exactly the same. But yesterday, we found what happened to mass? Shahira?
The mass changed.
So, what's the difference between the chemical reaction of making glue and the chemical reaction of placing that tablet into that water? How come we saw mass change in one of those, but not the other one? Track to Caleb.
I think the mass changed in one and not the other, probably because when we made the group, there wasn't much of bubbles, so probably because of the bubbles, it didn't go into the air. But in the second experiment, there were bubbles, so they probably transferred into the air instead of the group.
All right, that's an excellent hypothesis right there. And what we're going to do today is we're going to test Caleb's hypothesis and find out if that's exactly true. So what we're going to do is we're going to conduct a similar experiment to yesterday, but we're going to do it today in what we call a closed system. Take what you know about an open system and create a prediction. What do you believe a closed system might be? Mecca?
I think a closed system is like if we were doing a closed system is like how we were talking about yesterday, how you bought your wife a new bike and the paint was keeping it from rusting because it was keeping the water from touching the iron. So whenever when she scratched it and the water touched it, it rusted up. So that's an open system because it allows the chemical reaction in a closed system when it's closed.
Closed system is kind of when it's closed. There's no way in, there's no way out. Alan, if your head goes on the desk again, you will have a level 2 for sleeping. It is never appropriate to have your head down in my class. So, scholars, we're going to conduct an experiment today where we have a closed system and we need to pick up a few supplies. Over here, you have one little cup that has a tablet inside of it. You'll grab one of these. You'll grab one closed system, aka a Ziploc baggie. Next up, we've got one glass of water with these cute little ducks on it. When you guys are carrying this glass of water, this little guy is pretty fragile. They're flimsy. They're cheap little guys, but they're going to serve the purpose for us. So you've got to be careful. We can't have any water spill on the outer edge, because if it does, it's going to compromise your experiment, meaning that your experiment's not going to work exactly correct. So here's how we're going to pick up today. That one's a little wet, so I'm going to move that back there. Partner A, you're responsible for picking up water. Partner A, raise your hand right now. All partner A's. Left side. There you go, partner A's. What are you picking up?
Water.
Partner B, you are responsible for picking up the tablet and your closed system. Thank you so much. Edward, you're welcome to do a lap with the class if you'd like to. Just one though. Great job, guys. All right, this is where it gets a little tricky today because we've got to manage to get both of these cups in the plastic bag without spilling them and causing our chemical reaction to happen early. So I'm going to show you exactly how we're going to do this, and we're going to use teamwork in order to get this job done. So I'm going to take my system and I'm going to make it open. I'm going to have you guys wait until I tell you to go. I'll give you the allotted time for it. My system's open, sitting sideways on my desk. First, I've got my deck cup full of water. I'm going to take it, I'm going to slide it right inside of here. Now I've got to be careful. I don't want him to spill inside this system yet. Next, I'll take my tablet, I'll slide him in there right next to it. Here's where it gets tricky. We need to make this open system a closed system. And it gets rather difficult because we've got to try and take out some of that air in there also. So one partner, you'll simply squeeze on the sides here, getting that air out. The second partner will take and ziplock your system all the way until it is 100% closed. Both cups will be upright, and you will not spill anything. Before we begin, we need to brush our tablet. Pause. Remember, we're not murdering the tablet. We're simply breaking them into 3 to 4 pieces. You have 5 seconds to break the tablet up. Go. 5, 4, 3, 2, 1. Your tablets are broken. You're done in 0. Great job. Next up, you and your teammate have 30 seconds. Make this a closed system. Go. Second. Back in 3, 2, 1. Back in 0. I want to give you you guys a reminder. When we're working in with our teammates, we're working with our shoulder partner only. That means that if you are turning around and you are talking to other people, you will earn 1 for distracting others. Or use some self-control today. All right, guys. Tricky part here too. I'm sure you guys are going to be able to handle this because you've done an excellent job in the past. You take your experiment. It's in the sealed container. We need to measure the mass of it before we cause our chemical reaction, Justin. So what we're going to do is we're going to place it directly onto the center of our silver plate, and we will record down our mass. You have 10 to 15 seconds using the scale, and then that scale should be passed back to the next group. We should be done in no less than 1 minute. Go. Okay. Excellent job using soft voices. We're back in 3, 2, 1. Back in 0. Justin, you have 1. All right, guys. Now it's the moment we've been waiting for. Right? Chemical reaction. The way that this is going to work, we need to make sure that we don't spill this material all over ourselves. There is nothing worse than spilling water all over your pants, because someone might confuse this water for you peeing your pants. So we need to use extreme caution as we are doing this. The way that we're going to do that, when we cause our chemical reaction, we will simply take our cups. Justin, you have 1 head up. You will take your cups, we will tip them over so that the reactants mix together in the bottom of the bag. You will hold it by the part that ziplocks. Holding by the part that ziplocks. That way, if this baby breaks open, you aren't the student that's going to be known as pee pants. Get ready to start your chemical reaction in 3, 2, 1. Make that chemical reaction happen in 0. At this time, record your observations. Great observation. Eyes back in 3, 2, 1. Eyes back in 0. Here is probably the trickiest part of all of this. I'm going to need a scale for the scale on the bar here, so I'll give it right back to you. The trickiest part of all of this is trying to find the total mass at the end. Here's why it's tricky. I place my bag on the scale. I got a slight problem happening here. Who can identify what my problem is? Me check.
So the plastic bag is off the scale.
You got it. The plastic bag is really hard to keep on the scale because the liquid kind of wants to flow off the edge here. Am I going to get an accurate reading if my water's off the edge, Stephen?
No.
Absolutely not. So we need to make sure that it's all the way on here. If it's not all the way on, your numbers are going to be off and you won't get the results that you desire. Right now, if you have a scale on your desk, 10 to 15 seconds, find that mass, pass those scales up. Your eyes in the front. 3, 2, 1. Eyes in. 0. Need all eyes. Pause if you're checking your adjustment instruments. That's all right. If you have found your mass of your experiment, take your experiment, slide it to the front of your desk so that it is not a distraction for you. I should not hear any of the crinkling of the bags at this time. I want you to take a book from underneath your desk while I write the referral form, and you are going to be reading silently. Go. actually reading, then I will allow you to go. Until then, Alan, you will wait patiently. Back in 3, 2, 1. Back in. Your book is closed and I'm going to do that. Go you have 1. What happened to the mass in your experiment? 2, 3, 4, 5. Abdul. Excellent. If your mass did change, it might be simply because your scale was a little bit off, such as you had placed it flat on this area, and then I saw some of us, we had it right on the crease there. When it's on the crease, it creates a 1 to 2 gram difference that occurs there. That's my fault. I should have clarified with you what was happening if that was the case. What are some of the observations that you noticed in this lab? Raekwon, what's one?
I noticed that the bag had more air than it was from the start.
Excellent. Anaya.
I noticed that, like, is it called alpha something?
Mm-hmm.
It was designed in the morning.
Excellent. Amy.
Something else I noticed is that it's clear and then it looks like soda, like Sprite.
All right, excellent. Meshach, another observation.
I realized that the bag started to get cold.
Ooh, definitely a temperature change right there. Great observation. Take one more, Shahira.
There was bubbles.
Ooh, bubbles. Bubbles are always a sign there's a,
Phase change.
not a phase change. They're a sign it's a what, Abdul? It's a
Chemical reaction.
excellent. It's not a sign that it's always, but it might be. Why did our mass stay the same today? Miranda.
Our mass is the same because it's a cold system, and that means that the molecules in it stay.
Excellent. Achievement credit. Great job. If we open that bag, what would have happened to the mass of our system, Joshua?
The natural decrease because some of the particles from the water would have escaped the bag.
Excellent. Now you guys might be thinking, Boone, what's a chemical reaction in a closed system really doing for us? Turn to your next page. I'll show you. We can use chemical reactions in a closed system for a lot of great things. And one of my favorite things when I go to fairs and festivals is I love to see the glow sticks and the glow lights that a lot of people have out there. That's actually a closed system with a chemical reaction occurring in there. So let's see exactly how that works. Drop your eyes in. What happens to mass during a chemical reaction in a closed system? Getting started. Go ahead and pick up Miranda.
Getting started. Did you know that when you play with the glow stick, you are watching a chemical reaction in a closed system? And Klein is learning about what it means for chemical reactions to take place in a closed system. The sandwich bag experiment was amazing. When you combine the reactants in the bag, you observe a chemical reaction inside a sealed bag. Scientific form is a closed system.
Nothing was added to the chemical reaction while it was taking place, and nothing was allowed to
Escape.
an everyday reaction in closed system, glow sticks. Julie.
Have you ever played with glow sticks, necklaces, and other items that you can buy at parties, concerts, fairs, and festivals? All of these glow items are examples of chemical reactions in a closed system.
Jacoby.
When you buy these items, they may already be glowing. In that case, someone has started a chemical reaction. They do this so you go see the colors and want to buy something. If you buy a glow stick, a glow item that is not already glowing, you need to start the reaction yourself.
Some emergency lights that people keep in their cars need someone to start the reaction. Some hand warmers work the same way. Eyes up. Cosign if you've ever had those hand warmers before. Alan, what did you have to do to get that hand warmer started? Has it been a while?
Yes.
That's all right. Who else has used a hand warmer here? Anyone recently? It's been really chilly, none of us? All right. Well, when you get a hand warmers are just little things that come in a package. You tear open the package, and they don't seem like anything special. It's just kind of like a gray bag. And you're like, okay, that's not exciting.